Hello. I'll quickly take you through all the apps what I have created for Navy. So once you open the the solution file, this is what you have, and you click and run it. So the code will open up, and this is what you have. You have the 3D window, you have the 2D graphics window, and also I have incorporated components inside over here. I haven't started using it much. I need to do some more work on that components part. You have the animation buttons, and here whatever object what you create, the list will pop up in this window, and you can zoom to each object what you create. And this is the home button, and this is the one which goes to the earth fixed mode, and this is all for editing each object what you have listed here. Each and every tab denotes some apps what I have developed. So I'll show each one of them. The first one is general scouting. General scouting is basically there is a start point for a ship, and it is supposed to reach a final destination. If the ship is at some point today, at this particular time, the ship has to reach at this latitude and this longitude, and the ship has to move in this direction, and this is the current lat long of the ship. And when I click on auto route, what it does is this is my initial latitude 11 and 70, and this is my final latitude 14 and 71. And if the ship starts moving in this direction which is 0, in this direction, at what point it should return back so that it reaches this destination at this particular time. So that is what you are supposed to compute. So if I change my direction from 0 to 45 degree, from this you can see that the ship starts moving in 45 degree, and I can change my speed, I can change my initial lat long, etc. There is one more algorithm inside it which does the same computation, but it is much quicker. So if I click compute, I am choosing basically another algorithm to do the same computation. So almost the same results what you get, but that computation takes very less time. So that was the general scouting, and you have a few more other things to increase the tolerance, and also you can zoom into that ship using the zoom button, and you can delete that ship. So that was the general scouting. You can play around with it. After you finish off with every tab, you can click the remove all so that it deletes all the object in that tab. So I click on remove object. So now let me show you the next one, which is called expanding square search. Here you provide an initial lat long for the ship, and you have to find the route so that it does an expanding square search. There are certain values which you can play around with, like the sweep width, the coverage factor, and the search plan, and also the search direction. And you can see that this is what it creates. It kind of creates a kind of expanding square search, and you can even change the search direction. You can see it rotating, and you can increase its size. Maybe if I change it to coverage factor of 2, you can increase its size and decrease its size. That is the expanding square search. And you can again zoom into it, and you can even extract the reports associated with it by clicking the report button. So that is the expanding square search. So again I will remove all of these. Then I will go to, I'll skip to rectangular parallel search, this one. In this case you are supposed to define a region. So once I click on edit start, I can define the region where I want to do the search, and then you can define the route for the ship. For example, by giving the sweep width and coverage factor, it creates a track space. What should be the track space between the route, and search creep, whether it is horizontal or vertical, and what kind of vehicle you are using. So I'll choose ship, and when I click on create route, you can see that this route is created. And if I want to increase the track space, I will put this as sweep width as 2. So now you can see you must click on this track space to change to compute what will be the track space. So basically sweep width and coverage factor, you can compute what is the track space. When I click, you can see that its thing increases. And also there are certain other options. At this moment it is starting from the left bottom. I can make it as left top, so that means it will start its route from here. You can see it starts from here, and in the same way right top, so it starts from here. And when you animate, you can see that it starts from there. And also there is one more option, which is horizontal or vertical, whether you have to move in this direction or the vertical direction. So when I click on vertical, it goes in this direction, the ship starts moving in this direction. And you can click on this display. Sorry, this. So you can click on this display button, and you can see the dynamic display over here as I animate. And also in the same way you can zoom into that ship using that zoom button. This is what the rectangular square search, and the same way you can create route and display some results also, and you can get the reports from the report about that ship using that ship report button as well. Now you can do the remove all. I'll go to the next one, which is the maritime survey. So basically in this one, just to demonstrate how you can track some moving ships, you first click on the load the ship. So there are, you can see random ships moving, and when I animate, you can see all the ships moving by. Here our objective is to launch an aircraft from this aircraft carrier and go and intercept each ship. So basically since all these ships are moving, you have to find an intersection route. I have some algorithms already written for it. The first thing is like which ship, how to go and intercept each ship. The other thing, then the second thing what you want to do is what will be the optimal route. So first thing is identifying the route it has to take to intercept each ship. The second thing is which will be the optimal route. Find the optimal route. I have implemented some genetic algorithms also. Please note that this algorithm, some extra work has to be done, but at the moment it is not giving me a real optimal result. So you can see as soon as you click on compute route, it is trying different routes, and it is trying to get an optimal route to intercept all these ships. So you can see at one moment it looks like it reached an optimal route. You can see it keeps computing. Basically it uses the genetic algorithm technology for it. I have to do a bit more work on it to get the results. So let this computation finish. So basically the more generation size and population size you provide, the more accurate your results should be. Okay, it is done now, and now what you can see is see from this aircraft carrier, if I start animating, you can see that there is an aircraft which starts from the aircraft carrier and it is moving towards ship 1, and this ship, ship 10 has already started moving, and the direction in which it starts move is exactly in the direction the ship reaches. So the ship 10, then it goes directly to ship number 15, and then it goes to ship number 13, it goes to ship number 3, like this. So you must have noted that the results is not very optimal, so some extra work is needed here, but still it goes to each ship by identifying the direction in which the ships are moving. So that was the mission planning one. So we'll go to the next one, which is what I created for Navy NCO. This is another division. Here again I'm loading all the ships, some 13 ship. Here you have to do it in a particular sequence. You have to first load the ships, and then in this case I'm considering all the ships as static. So I have, you can see all the ships are moving, but by clicking on the static ships, all the ships become kind of static, and there is an aircraft carrier over here that will be the only thing which will be moving. So all the ships I made it as static ships. So our objective here is to create a path plan to intercept all these ships. Okay, so in order to do that, you have to go back to the rectangular pattern search, because I didn't want to recreate the same thing what was here again back in here. So here please note that you have to come back to the rectangular square search, parallel search, and create the region what you want to analyze. Click on OK, and then you choose your route and give a sweep width of maybe 50 vertical, horizontal, and you have to choose air here, because this is an aircraft what it starts flying from the aircraft carrier, and it has to intercept all these ships. And clicking on create route creates a ship route. Now I have to come back to this button. There are several criteria what you have to consider while this route is getting created. First is the clustering. That means when there is a cluster of ships, you can see this, there is like a group of ships here, there is a group of ships here. When there is a cluster of ships, its speed has to change. So the first thing what we need, like you have to define what is the properties of the cluster. You can define what is the minimum distance between the ships and number of ships to identify what is the cluster. So that is this settings here. And when it is inside the cluster, what should be the speed of the aircraft? So that means after you define the cluster, this speed will be taken out, and then you can provide the details of when it is near to a ship what it should do. That means when it is near to a ship, you can define the speed should be this much, and from the ship it has to be this much distance far. That means you don't want to go very near to an enemy ship, so how much distance you have to keep from that enemy ship, and also how much time you need to identify that ship. That means your aircraft has to spend like 5 minutes to detect that ship. If you can change these times also, and also what is the default criteria, like what is the surveillance speed. That means if it is not inside the cluster, or if it is not identifying a ship, what will be should be the general speed of the aircraft. And this is the endurance time. That means how much time the ship has, how much time the aircraft has. It has a flying hour only for, it has only 5 hours to fly. So it has to make sure that after 5 hours it has to come back. So every time the aircraft is flying, it has to compute the distance back to the aircraft carrier and find out how much time it will take considering the default speed, and also should be the altitude of the surveillance aircraft. It takes all these things into consideration, and it does the clustering, speed change, everything by just clicking this button. It is doing all these operations, and it will create the final route. It basically creates a great arc as well as a AMM route. So it takes a bit of time to do the computation. So you can see here that while doing the compute, it has identified the cluster region, because there is a group of ships here. There is a group. You can see those boxes being drawn. There is a blue one, there is a yellow one, and there is a red one here. and it is creating all the routes, and you can see those lines going towards each ship. That means whenever it has identified the ship, it is taking the route towards that ship. So the ship starts from this aircraft carrier and it creates all the routes. So these routes are created. I'll show how these routes are done. So I'll show the AMM route. This is the AMM route. What is done? So this is the aircraft. So let me show near to the ship. So on ship page you can see that the aircraft was taking a circular pattern so that it spends this 5 minutes here, and also there is a standoff distance of 5 meters. I think this is meters. 5 kilometers, so that it stays away from that ship. So this is the two routes. This is basically the AMM route, and this is the Great Arc route what it has computed. And the next thing is you can also create find out what is the communication availability. See, your aircraft carrier is moving from here. So during its route, what is the communication availability? You can say that the communication is available for 150 kilometers from the parent aircraft carrier, and when you click on it, you can see that during its flight, wherever there is blue, there is a communication possible with the aircraft carrier, and wherever there is red, the communication is not possible. So if I change it to 200 kilometers, you can see that it's slightly increased. The other thing what you would like to see is how much time the sensor on the aircraft has spent in this particular region. So I can choose aircraft here, and I can do a coverage computation. I am getting a grid of 9 kilometers, and it creates a grid over this region to compute how much time the sensor on this surveillance aircraft has spent over this region. So you can see that see, this is the time spent by the sensor of the aircraft. You can see when it is inside the cluster, it has spent more time. You can see brighter color over the cluster region, and whenever it is on top of ships, you can see that the color is much more here. So you can see it has spent more time whenever it has identified each ship. So that was the output options. Then you have the endurance limit. Endurance limit shows at what is the point in which the aircraft has to return, so that it keeps this endurance time limit. So it says like by 31st October this time the aircraft has to come back, otherwise it is going to cross this endurance hour. Basically the same algorithm I have. There is one more way in which you can do it. Basically, if you click on cluster wise route, it completely splits up the region into various clusters. That means it will be a lot of squares, and it completely entirely rather than adjusting the speed, it will have different regions. You can test it yourself, because this thing takes a bit more time. So I just do remove all, and then we will go to the next one, which is the detect a pirate ship. See, this algorithm what I've shown here, there is some more explanation given in this PowerPoint. I'll send you this one also, like how I have done it. And okay, coming back to this detect pirate, here you have a number of ships. Maybe you can think like you have 4 ships, and all these 4 ships, and there are 2 unknown ships in the sea, and all these the radars on all these 4 ships knows the bearing angles of the unknown ships. So the first has got 2 unknown ships, the second has 2, so they just know only the bearing angles, and from this bearing angles we have to detect what is the location of those unknown ships. So I basically create vectors, planes, and create the intersection point of all the bearing angles from these 4 ships to find out what will be the possible location of unknown ships. So I'm going to load all the ships here just to prove the point. There are 4 ships, okay, 1, 2, 3 and 4. These are the ships, and we know only the bearing angles. These are the unknown ships, Pirate 1 and Pirate 2. Basically I have just shown it to display its location, and I'm taking only the vectors from ship 1 to ship 2, ship 2 to all these 3 pirates, only the bearing angles. That is the only info what I have, and I'm basically computing the location. So to do that, you have to click on create the plane vectors points. So it creates several planes vectors, all the necessary planes vectors and points. And once you do that, once you know that it is done, you can click on this animation button. You can click on this animation button, and you can see that it has automatically computed the routes, computed route 1, computed route 2, computed route 3. Based on those bearing angle information, it has computed all these routes, and you can see that it is well coinciding with all these pirate ships. So to show that in details, basically this is what it is doing. It has created several planes and along the bearing angles. So if you consider ship 4, this green is one of its bearing angles, and the ship 3 bearing is not getting displayed. I'll just open, go here. So all these bearing angles intersection point, it is going to consider as a route for the ship. So I'll just click on this one. You can see the computed route, how it is getting calculated. This is the computed route. Basically it takes the intersection point of all these planes and find the computed route. This is what it does. Okay, that is all. And here you can use to zoom it to each one, and also there is a navigational chart. Once you click on it, it basically puts a navigation chart here. Okay, if you have any questions.